So I've been asked by members of my class to elaborate on this weather phenomena that we've been experiencing for the last few days. So I'll start with a sort of a very rough view of the Eastern Shore and the Chesapeake Bay, Atlantic Ocean, and indicate a few things that have impacted this entire weather phenomena. First of all, there has existed for a week and a half or so a very strong high pressure system at the border of the United States and Canada. Simultaneously, has been a low pressure system existing roughly on the coast, on the border of Georgia and South Carolina. Well, you may know that low pressure systems have a tendency to rotate counterclockwise. High pressure systems rotate clockwise. Simultaneously, in the Caribbean, there has been a rather significant Category 3 or 4 hurricane, which has moved from the east to the west, sort of lingered in this area for some time, and then was undecided which way that it wanted to go. And some models had it striking the eastern shore, some models had it striking north of South Carolina, some had it going out to sea. We have experienced an unusual amount of flooding in the last few days, and part of that was due to the interaction between the high and the low and the hurricane, but also a nor'easter, which by definition comes from the northeast and has considerable duration, wind speed, and moves a great deal of water in front of it. So what you have here are the elements of a perfect storm, if you will. So as the nor'easter approached the eastern shore, obviously it created a significant amount of high energy wave action, high waves, high tides, tides building up on other tides, and as a consequence, the result was some considerable flooding on the seaside of the eastern shore. Simultaneously, this very strong high began to move to the south, which created a bit of a pressure gradient between the high and the low. The wind that was generated by this pressure gradient moved in this direction. But keep in mind, the broad sweep of this high pressure, due to a variety of things, including the Coriolis effect, moves in this direction, whereas the low pressure moved in this direction. At some point, which is roughly in the area of South Carolina, this front actually stalled due to the fact that this is much stronger and simply kept moving in a circle, picking up a lot of moisture from the ocean. When it interacted with the warm air here, obviously resulting in a great deal of precipitation, somewhere in the neighborhood of 22 to 24 inches over a 2 or 3 day period. Getting back to the Chesapeake Bay, of course, the winds from the hurricane, which has since moved offshore, are forcing an unusual amount of water in the bay and causing one tide to build up on the previous tide. So instead of like a high tide, low tide, you have a high tide stays, and another high tide builds up on top of it, which caused flooding, obviously, on this side of the bay. Interestingly, over the last few days at various points, various places like Sewell's Point and others, the high water mark reached a height probably of about 6.8 and has now come down to about 5.5 as these winds have diminished somewhat. So as a consequence, all of this buildup of water in the bay eventually will find its way back to the ocean, relieving the eastern shore and the bayside from its flooding condition. And as the nor'easter begins to abate, the flooding on this side will also change. And probably within 3 or 4 days, we'll return to a circumstance of being somewhat normal. This was all caused by high pressure, low pressure in this hurricane, and low pressure again in the nor'easter, which I guess you could say is a perfect storm. And as I told my students, this is why we had flooding conditions for the last 2 or 3 days, both on the bayside and the seaside.